Hello there, and welcome to my lesson. Today I will be teaching you how to create the basic graphical components and control flow for a turn-based game. I'm going to run it now. Okay, so as you can see here in the console, it's asking me where it wants me to put something. So I enter a number. It asks me where I want, like the y coordinate where I want to put it, so I enter another number. And this little face appears on this map. And then the game asks, hi there, where would you like me to go? As if the character is asking me that, and then I answer. Here, watch. So if you look at the console, it repeatedly asks me where I want it to go, and then I press N for north, W for west, E for east, S for south. Just watch don't watch the console now, watch the game, or the graphical bit. Alright, there you go. So, as you can see, the character moves up when I type N for north, down when I type S for south, right when I type E for east, and left when I type W for west. Now I will start explaining how to get the computer to do this. Firstly, like last time, there's going to be some starter code posted in the description of the video, and it is not the same as last time, so I will need you to quickly copy and paste that code into a new REPL that uses the language Java Swing before we get started. When you create the REPL, do not pick just Java, pick Java Swing. These aren't two different languages. Java Swing just means that we want to use Java and have some graphical tools enabled, which are not enabled when we pick just Java on the REPL website. So again, I haven't explained enough of the basics to talk about why the starter code is necessary, but we will get to that in a future video. So now I've opened a different file than the initial one, and I'm going to start explaining some of the tools I used to create what you saw there. So, if you remember the last video, you might remember that I demonstrated how to do something called creating a variable, which means reserving a space in the computer's memory for some information that will be determined when the program is run. You might also remember that the only type of information that I got the computer to remember was called a string, which was a bunch of characters saved in a specific order. The other thing you may remember is that I typed all my code between the open curly bracket after the line containing the words public static void main string args, and before the next close curly bracket, not including curly brackets that we added while we were coding. So that's this open curly bracket here that I'm referring to, this one, and this close one. Now we will be typing code in 3 different places, one of which is the same spot we used last time, which I will call the main block, another of which is after the curly bracket with the words public class main extends JFrame, after this curly bracket right here. Okay. And before the line with the words public void paint, right here. And I'm going to call this space up here, I'm going to call this the intro block. As you can see, I've labeled it here. And the last of which I'm going to call the graphics block, and it is in between the set of curly brackets after the line with the words public void paint graphics G. This here is the graphics block. Code placed in different blocks will do different things. We will declare all variables, however, in the intro block right here, okay? And we will need to use the word static before each of them. Again, I will get to the purpose of the word static when I have shown all the basics. So declare it like so. Static string the name equals open quote, hi there, close quote, semicolon. Note that when you are creating variables in the intro block instead of the main block, you should give them some kind of initial content or value on the line that you declare them, like I've done up here. If we remember correctly in the last video, I always gave it its value or its content on a line separate from the one where I declared it or created it. Now I'm doing that on the same line. And remember that you can always change its value later, but you should start by combining the declaration statement with the first assignment statement. Next, all command lines where we are not telling the computer to change what it is displaying up in that window over there on the top right, and we are not declaring new variables, all of that code goes in the main block here, okay? This here is all setup code, and this here is not. So, all print statements, all conditional statements, and any statements changing the values of variables, except the ones integrated into the line where we declare the variable, go here in the main block. Now I'm just going to run this code for you really quickly. So, as you can see, just like last time, the computer printed out a whole bunch of random junk before doing anything related to my program. And then it printed out the hi there, which was what I told it to print in the program here. As you can see, I declared this variable, and then I told it to print out its contents by putting its name there between these brackets. Okay, before I go on with my planned lesson, I'm just going to review how if statements work and how else statements work, and quickly show you how something called else if statements work. And these are things that I showed you later on in my lesson, except I didn't do a very good job of it, so I just want to clarify that now. So before I do that, just note that in this new file I've opened here, which I'm not expecting you to make a copy of or write anything yourself, I've just created these strings with these values here in the intro block. All right, I'm going to post something on the side of the video with the name of each string and each of their values. So now I'm going to show you what my code here does. So first I have the computer print out a, and then, well, no, first I have my setup code. Then I have it print out a bunch of blank lines, just so we don't get the actual useful stuff confused with all the random junk that appears at the top. And then here I have, wrong line. This line here, as you can see, this is a print statement with no ln after it. That means it's going to print out a and then a colon and then a space, but it's not going to move on to the next line. So whatever I print in my next print statement will be on the same line. And the console is this. If I had put print ln and then this stuff, then the two things would appear on different console lines. But because it's just print, it's going to be on the same line. So this here is something I went over in the last video called a conditional statement that I'm just going to refresh you on. Basically what it does is it checks if this condition is true, and then if this condition is true, the code in the curly brackets after it runs. So this code here would run if this condition proved to be true. All right. And then after the if conditional statement up here, you can see an else statement. And how that's going to work is the code in the brackets after it is going to run in the event that this condition here is not true. So if this proves false, this code here will run. And if this proves true, this code here will run. And I've already run the program, and ignore the stuff after the first line that has the a colon on it. So as you can see, it printed out 1 because the string does in fact have the value hey dude. Okay? Now moving on to the next set of commands I've set up. So I get it to print out b with no ln, so that the next thing that gets printed prints onto the same line as it. And then here I have a normal conditional statement where I test if another string has some specific value, and then I have it print out 1 if it does have this value. And then after that, I have something called an else if statement. This is something that's new to you. I didn't go over this in the last video, so if you don't remember it, good, that means you're sane. So what this does is it only checks this condition here. Sorry, that's not the condition, that's including the if. This condition here, if this condition is false. So if this condition is true, then it just runs this code and skips this entire statement, okay? But if this condition is false, then it checks this condition, and if this condition is true, then it runs this code. But if this condition is false, then it skips this code too. So it would have skipped this and this if both of these conditions are false. So as you can see, it actually didn't print anything on the same line as the b. I mean, I added it didn't print anything on the same line as the b colon because neither of these conditions proved true, neither this one nor this one, okay? And then I added a println statement, like a blank one, just to have the console cursor move on to the next line so that the C would print on the next line instead of the same line as the B. All right, so now for the next set of code I've set up, here's the next set. So now I have an if statement and an else if statement, which you know how they work. And then I have an else statement after that. Oh, sorry, I scrolled down to the next set. Let me go back up. All right, so here's how this is going to work. It's going to print out a C, then it's going to check if the third string has this value, and it's going to print out this if it does. Sorry, no, it's not going to print out the entire statement. It's going to run this code. It's going to print out this here. And then if this is false, then it's going to check this, and it's only going to check this if this is false. Then if this is true, it's going to run this code, all right? And then if this is false, because there's an else statement after the else if, then it's going to run this code. So this runs if and only if this is true. Sorry, not this runs. This runs if and only if this is true, okay? And then this runs if and only if this is false and this is true, okay? And then this here runs if and only if this is false and this is false, all right? And as you can see, it printed out, you may or may not have fallen asleep on the keyboard because the third string did not have either of these two values, neither this one nor this one. Okay, moving on to the final set. So the only difference between the above set and this current set is that I have now added two else if statements, all right? This is fine. You can have an unlimited number of else if statements after one initial if statement, because this content can run if and only if this is false and this is true, but this content will run if and only if this is false and this is false and this is true. And then if I added like another else if statement here, else if, then its content would run if and only if its condition was true and this condition was false, this condition was false, and this condition was false, okay? And then this else statement at the end runs only if all the conditions before it, so this one, this one, this one, and this fictitious one that I haven't written in, if it was actually there, would all have to be false for this code to run, okay? So just remember that you can have an infinite number of else if statements after one if statement, because the only thing you need for an else if statement to be legal is to have some condition getting checked above it. However, you can only have one else statement after an initial if statement, because once you have an else statement, you can't have any other else if statements or else statements after it unless there's another if statement after it. Here's what I mean. So we have an if here, then an else if. If we were to put an else in here, then this wouldn't work because no condition is being checked above it. Like, yeah, these conditions here, this one here, and this one here, do get checked before we get to this, but this has to actually logically be an alternative to something for this to make sense, and it isn't if there's an else here, because it's if this, do this, if not this, but yes this, do that, otherwise do the content of this else statement. Again, this is just a comment because there's two slashes before it, so it's not actually going to do anything. But then if the computer gets down to this line, it's going to be like, oh, hang on, what is this an alternative to? It's not an alternative to anything. All the alternatives for this were already considered, so crash. This doesn't make sense. But it will work because, again, this is just a comment, and it's not actually an else statement. And then, yeah, again, there's our final else statement is here. If we were to add another like else if statement down here, that were actually a real one and not just a comment, that would also not be legal. That would cause a crash because it's right after an else statement. But it's not like once you have an else statement, you can't have any other else if statements. Like if we added an else statement, then another if statement, then another else if statement, then that would be fine. Okay, I think you understand. Now, back to the lesson. We can create variables of different types. Strings are the only ones I've shown you so far, and ints, meaning integers or numbers with no decimals or fractions, are the next that I'm about to show you. Let's start by declaring some int variables. So let's move on to a new file where I've declared some. So if you look at this file here, you can see that I have added declarations of two integers as well as just this first string. So I type static int, then the name, which I chose x, then equals 0 because I wanted to give it an initial value, then a semicolon because you have to end all command lines with semicolons. Now we can use these variables in conditional statements, print statements, assignment statements using sc.nextInt instead of sc.nextLine. If you look up here, you can see I've demonstrated how to type sc.nextInt. It's not the same thing as when you get the computer to wait for user input and the user's inputting a string. Here it means they're supposed to be inputting a number. And we can also use these variables for two things I haven't yet shown you, called mathematical operations and graphical commands. Before going on, I would like to let you know that until we get further on and I can explain things in more depth, every time you use a command containing the subcommand sc.nextInt, you should follow it with another command containing nothing except the subcommand sc.nextLine and a semicolon. Do that like so, just like I've done here in these comments. I'm not going to be uncommenting these because they're in the wrong block. But okay, now let's start with some context about conditional statements using ints. So conditional statements with integers can use equals equals, like this, okay? Less, or it's greater than, less than, but can never use just equals like this, and can never use dot equals like this. The reason we can't use just dot equals is because that's for comparing strings and some other things, not for comparing ints. And just one equal sign tells the computer that it's an assignment statement and we're giving it a new value, which is not what we're doing. We're testing if it has a certain value. Now I will show you an example of each type of conditional statement. So if we scroll down here, you can see that we have an initial conditional statement which checks if the integer x has the value 0, and if it does, it prints out this. All right. Then, as you can see here, I have got the computer to wait for user input and then assign the number the user puts in to x. Then I have done this just because I'm supposed to do that after I use sc.nextInt. Okay. Then next, you see here another conditional statement where we're testing if x is less than 2. These signs here mean that we're testing if the number on the point side is smaller than the number on the open side. Okay. And then I've told the computer to print out lower range if this proves to be the case. The next thing you see here is called an else if statement. This works the exact same way as if I had just done this. I'd put an else statement, then an open curly bracket, then an if statement, then the condition. As you can see, this condition here is the same condition. And then in the body of the if block, I put whatever's in the body of the else if block, and there's nothing except the if statement inside the body of the else statement. So this here, all this, I just condensed into this, and they're completely equivalent. So anyway, what's happening here is if this is not the case, then the computer checks if x has a value greater than 8, and if it does, it prints out upper range. And then if neither of these things, neither this nor this proved true, then it executes this block of code and it prints out mid-range. Just ignore this stuff here for now. All right, now I'm going to run the program. All right, so now it has started running, and as you can see, it printed out the usual random junk. Then it printed out hi there, and it printed out x equals 0 because it did. And now it is at this point in the code here where it wants me to input another int. So I'm just going to input the int real quick. Let's say 4. And then it prints out mid-range because that's not less than 2 and not greater than 8. And then this 9 here you can just ignore for now, because actually I'm just going to explain what that is right now. So this 9 being printed out is a result of these two lines that I told you to ignore for a second, these two. But what the first one is it's called a mathematical operation. It's an assignment statement where we give a new value to the variable x, except what we've done is actually done some math over here. So what the computer does is it evaluates the stuff on the right side to a number. So it takes the current value of x, it adds 5, and then it assigns that value to whatever variable is on the left. So x now gets the value that x initially had plus 5. So you can also have subtraction using this sign here, or multiplication using this sign here. There's also a way to do division, but I'm not going to bother showing that right now because it can actually cause a lot of problems. So I will get into that later though, but just not this very second. And then this here just gets it to print out the value of x currently, this last line. So basically I entered 4, then it added 5 to the current value, which was 4, and then it printed out 9 because 4 plus 5 is 9. Now I'm just going to back out of this file, go into another one, and I will show you how to make the computer draw shapes in the panel on the right. So here we are in the next file. Just ignore it for now. I'll tell you when to bother looking at it, but right now basically just listen to what I'm saying. So whenever we want a command to do anything graphics related, we need to put it in the graphics block. I don't have any code, like any working code here, so you're not going to see the starter code, but just remember that it goes in the graphics block. And we need to start that command with a G dot. Okay? So hang on, let me just type one in. Start the command with a G dot, like that, like system dot G dot. All right? So the first command we will want to use is one that sets the color of whatever we're about to draw. So to set the color we will be drawing in this graphics window. That's what I'm going to refer to. I'm going to call it drawing when we make stuff appear. So to set the color we will be drawing in, do it like so. G dot set color, American spelling, C-O-L-O-R, not C-O-L-O-U-R, like we do in Canada and a lot of other parts of the world. So G dot set color, open bracket, close bracket, and then between the brackets, color, American spelling, capital C, dot some color, all in caps, for instance, red, then the close bracket, which I've already told you to type, followed by a semicolon, just because every command line has to have a semicolon after it, except conditional statements. So that's the first thing we're going to want to do. Note that there's an existing set of pre-existing colors that we can use. We can't just pick any obscure, meaning not well-known color, like marigold, puke, yellow, evergreen. So the pre-existing set contains these colors: blue, all caps; red, all caps; gray, again, they're all caps; gray, black, dark gray with an underscore between them, like so. Dark underscore gray, cyan, white, green, light gray with an underscore, light underscore gray, cyan spelled like this, magenta, orange, pink, red, white, and yellow. And magenta is spelled like this, magenta. Yeah, there we go. So those are the colors. I didn't type all the ones, I just typed the ones that looked like hard to spell or had these underscores in them. Actually, I'll just leave those there. So the next thing that we're going to want to do is draw some shapes in the color that we set. So when writing commands that draw shapes on the window in the top right corner up here, which I'm going to make up a name for and call the canvas. It's not actually called that. I just want you to know what I'm talking about. When writing commands that draw stuff in the canvas, you indicate the position you want the shape to appear at using numbers, where the canvas can be represented by a graph where each pixel has one number representing its position from left to right and another representing its position from top to bottom, like so. This now becomes relevant. So this graph is a graph of like a 6 pixels by 6 pixels screen, where this space here would have coordinates 0, 0. This one would be 1, 0. This would be 2, 0. This would be 0, 1, 1, 1, 2, 1, etc. The coordinate from left to right is called the x-coordinate. The coordinate from top to bottom is called the y-coordinate. And we always say the x-coordinate first, okay? Another thing you can see from this little graph of mine is that when we go down, like if we're already at some pixel that's not the bottom pixel, and then we go down, its y value, like its top to bottom coordinate, actually increases as we go down and decreases as we go up. So you see increasing, 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 decreasing, decreasing, decreasing. This is the opposite of what you'll see in a math class. Don't be alarmed by this. Just take note of it and remember it when you are programming the computer to draw anything on the canvas. So pixel A is at position 2, 3, and pause the video now and take a guess at where pixel B is. Okay, it's at 5, 4, because again, we always say the x-coordinate, meaning the position from left to right, first, before we say the y-coordinate. So this here is a command we can use to draw a rectangle and then have it filled in. This g.fillRect, capital R, open bracket, and then 4 integers with commas between them all, and then a semicolon. When we type this command, we need to type these 4 ints, not these specific ones, just any 4 ints, meaning numbers that are positive, negative, or 0, but not fractions or decimals. We need to type 4 of them between these brackets, and we need to separate them with commas. The first 2 numbers, these 2 here, indicate the position that we want the top left corner of the rectangle drawn at, where the first number is the x-coordinate and the second is the y-coordinate. The next two numbers, are the width and height of the rectangle in pixels. The height of the rectangle measured in pixels. So the above command line, this one here, would result in the canvas looking like this, where R means the pixel is red, blank means it was whatever color it was before. So as you can see, we went top left corner is at position 2, 3, so we go 2, 3. Width is 4, 1, 2, 3, 4. Height is 3, 1, 2, 3. Draw the rectangle there and fill it in. And there we go. That's what the canvas would look like, assuming it was just 5 pixels again. Otherwise, it would look just like this, except with a lot more pixels that are not filled in around this. Also note that we can use variable names instead of just integer values here. So instead of putting 2, 3, we could say x3, and the computer would know to use the value of x as the coordinate. It wouldn't try to use the letter x as a coordinate. So it wouldn't try to put it at position x3. It would know to put it at position 2, 3, like this. So I will now show a command that fills ovals instead of rectangles. It works in a similar way to the previous one. The first 2 numbers, oh, hang on, let me just scroll down to the command. There it is, right here. So the first 2 numbers indicate the position of the top left corner of a rectangle, not of an oval, because ovals don't have corners. And the last 2, again, tell it the width and height of a rectangle, not of an oval. And then it just draws an oval inside the rectangle that we indicated. So the oval will be smaller than the rectangle, like than a rectangle would be if we gave it the same sets of numbers. So, for instance, the command g.filloval 2, 2, 6, 4 will draw something like this. Again, I used a bigger screen so it would be more visible. So this would be about what the oval would look like. This doesn't look like a super ovally shape just because it's really small and doesn't use very many pixels, but you can't actually draw anything round on computers. If you see anything that's actually round, such as this like REPL logo up here, it actually just looks that way because there's so many tiny little squares, like tiny little pixels, that you can't see the edges anymore. And that's basically what would happen with a big oval. Just, again, this is a super terrible resolution screen. It's 8 pixels, 8 by 8. You'd never, or sorry, 9 by 9 because of the 0th pixel. You'd never have a screen like that. Note that the pixel indicated in the top left corner, or sorry, the pixel indicated as the top left corner in the fill oval command is not actually filled in. This is going to be the vast majority, or sorry, this is going to be the case the vast majority of the time that you use a graphics command which produces an oval, because the oval shouldn't hit the corners. So if we want the shape filled in, we use fill rect or fill oval and put in the positions. Or if we want only the outline of the shape for some reason so that it is not filled in, we use draw rect with lowercase d, r, a, w, and then rect, capital R, or draw oval, lowercase d, lowercase r, lowercase a, lowercase w, capital O for oval. Yeah, those are the two commands we use if we do not want it filled in. Now, the next thing I need to tell you about graphics is how the code in the main block and the code in the graphics block interact. The way they interact is the computer will by default only run the code in the main block and will ignore everything in the graphics block. In order to get the computer to run the code in the graphics block, we use the command frame.repaint, like this. In the main block, if we use this command, the computer will jump to the beginning of the graphics block and then execute all the commands in the graphics block sequentially, as if they had appeared in the main block, starting right where the command frame.repaint was, and ending right before the command that was originally right after frame.repaint. For example, I'm just going to expand this window so it's visible. Okay, I'm back. So, we are now looking at this example here. So if you look at this code, note that I have the step indicated here, like what stage the computer is at. Here I have the commands that the computer is reading. Okay, sorry, that selected everything. I'll just have to edit it in. Circle around this here. Okay, and then here this is the console, and this here is the canvas. And this little arrow here indicates the code the computer is currently reading. Ignore the fact that my starter code isn't here, because this code is never actually going to run. It's just like a chart, basically. So here, as you can see at the first step, the canvas is blank, and the console is also blank. So if we go down to the second step, however, it has finished printing out what XPOS do you want the rectangle at, and is waiting for the user to put in a value for X, because as you can see, it's at this command here. All right. Then at the third step, the user has put in a value, which is 3, and then it's at the step where it's about to print out what YPOS do you want it at. It's currently reading that line. So then in the next step, it's already printed that out, and it's waiting for the user to input a value for Y. And then in the next step, I think I forgot to put in a number here. But it looks like in the step after that, the number I said the user said was 4, so I'm just going to put that in real quick. And then in the step after that, it gets to the frame.repaint command. As you can see, it started in the main method. And then in the step after that, it hops from here in the main block up to the graphics block. So they set the color to red, and then they fill a rectangle at coordinates x, y with width 3, height 2. That's what's happening in that block, but it's currently just reading this command. Okay, nope, sorry, I selected both of them. This command here, as well as the G. Then it's done this, nothing's changed, because it's just setting the color it's about to draw in. It's like picking a colored pen. Think of that being what this command is. Then it does this, it fills, or it's doing this right now, it's reading this line. And then in the next step, it's already done that. You can see the arrow is no longer here. The little rectangle has appeared in red. Ignore the fact that it's highlighted this line. You know I don't mean to do that. And then it has moved on to this command. It's hopped back into the main method after it finishes reading the code in the graphics method. It's currently reading this line. And then in the next step, it has finished reading and executing this line, and it prints out done. And that's it. So, as you can see from this very long chart, when we use the command repaint, the computer will continue to execute the code from the top of the graphics block, and when it is done executing the code in the graphics block, it will then jump back down to right after the repaint command line that sent it up to the graphics block. It jumps right down to back after that command in the main method, and then it continues executing command lines in the main method in sequential order. Also note that we can make the computer jump to the graphics block as many times as we want. We are not limited to just having it jump there once, like I did in my example. One small detail I did not mention earlier to avoid confusion: one of the lines present in the setup code does some setup stuff, but then also behaves like the frame.repaint command. So the graphics code should actually run once, even if you never use a frame.repaint command. Also note that if you draw a shape on top of another one that's already been drawn, the first one will disappear, or at least the part that's covered will just disappear, And also note that if you draw something with coordinates that are off of the screen, which large negative values will almost always work for, it won't appear. Okay, one thing I omitted in the previous section that I'm just going to show you now, before I move on to the next file I was planning to show you. When you use the g.fillRect command, you can actually use mathematical operations directly into, like, just put mathematical operations directly into the command. So as you can see here, I've set the value of x to 50, but because I've put x plus 100, this should evaluate to 150, and then the red square that this is going to be drawing should display equally distant from the top and the side of the frame that's going to appear up here on the right, because y is already set to 150. So I'm just going to show you how that works, like that it works the way I'm telling you it does, real quick. And this here is just the setup code, and I'm also just going to show you that even though I haven't included the command frame.repaint, it does actually run this code once. So I go run. And there you go. As you can see, it is equally distant from the side to the top. I'm just going to show you what happens now if I remove the plus 100. So just take a picture in your head, remember what that looks like. So I'm just going to actually, I'm not going to remove the plus 100. What I'm going to do is I'm going to copy the command, and then I'm going to paste it onto the line beneath it, and I'm going to remove the plus 100 on the line beneath it, and you're going to see that it's going to display two squares or an elongated rectangle because the squares are side by side. I haven't done the math yet, but anyway, now I'm just going to show you what happens. So I'm going to go stop, and then I'm going to run it, and there you go. Two squares. So as you can see, this mathematical operation that I've plugged directly into the g.fillRect command worked. So you can put mathematical operations directly in. That works for height and width, as well as the actual coordinates. Okay, now I'm going to move on to the next file I was planning to show you. So this here is the file I was going to show you, and this is working code, as you can see. So I'm just going to run it for you so you can see what it does, and then I'll walk you through everything I put in and why I put it in there. Alright, so as you can see, the computer has printed out hi there. I am waiting before displaying the face, comma, press enter when you want it to appear. So I press enter, and it prints out done and displays this little guy up here. Now I'm going to walk you through all of the code I used to make this happen. So right here is the beginning of the intro block. I declare the variable the name just to print out hi there. I don't need to declare a variable for this. I could just say to print hi there, but I just did this because I was copying my old code. Here I am declaring the variable x and giving it a massive negative initial value. The reason I'm doing this actually is so that the character starts appearing off of screen so that you can't see them before the computer brings it in. So if you have items that you don't want to appear till later, you don't have to like make them not appear using conditional statements in the graphics method. You can just give them values like coordinates that are off the screen and then change their coordinates to be on the screen when you want them to appear. Okay, I did the same thing for the y value. I gave it a massive negative value for its coordinate. So here in the paint method, you see that I have this line of code to set the color to red so I can draw the main rectangle, which is the background for the face. Okay, then I set the color to blue. I draw these two rectangles for the eyes, and then I draw an oval for the mouth, but you're probably wondering how it looks like a smile and not just like a open-mouthed expression of shock. The way I did that is I then set the color to red and drew another rectangle right above the oval. So it actually blends perfectly with the back half of the face and blocks out the top half of the oval, so you can only see the little bottom half, which looks like a smile. So next, I'm going to show you the code in the main method here. This is all setup code, so don't worry about it for now. Here, I just print out hi there, because remember I assigned the value hi there to the string the name. Then I have it print out, I am waiting before displaying the face, press enter when you want it to appear, and then I just assign the variable the name, whatever the user puts on the next line. It doesn't actually get used anywhere, it's just because I use the command sc.nextLine, the computer waits for the user to press enter. And then in the next bit, I change the values of the coordinate parameters so the face will actually appear on the screen, and then I use the repaint command to actually update its position. A couple additional things you'll want to note. When I draw and fill multiple shapes that overlap, the ones drawn and filled last will appear over top of the ones they share a space with. So that's how I got the rectangle to cover up the top half of the oval to draw the smile. If I'd drawn the oval after the second small rectangle, it wouldn't have worked, because the oval would have just covered the rectangle instead of vice versa. And if I had drawn the main rectangle, that's actually a square because I gave it height and width that are the same. If I had drawn this big rectangle after drawing these eyes and this oval, it would just, like these eyes and this mouth, it would just cover them up entirely and it wouldn't look like a face, it would just look like a red square. Also note that when you use the repaint command, shapes you have already drawn will not disappear. So if you want to have a shape move, you need to redraw some kind of background to obscure the shape in its old position. Furthermore, if you want a shape not to appear until some specific point in time, just tell the graphics method to draw that shape at coordinates indicated by variables, and give those variables starter values that are off the screen. Large negative values will almost always work for this purpose. Then, when you want to get the code in the main method to make the shape display on the screen, then you just change its position variables values to values that are on the screen and use the repaint command. Alright, now you've seen how this runs. I challenge you to create something just like it, except where the user picks the initial position of the character in game board spaces, not in pixels. So if the user enters 4, the character should appear like somewhere over here, not like 4 pixels away from the top left. And then the computer asks just once which way to move the character, and then moves the character one space over in the direction indicated by the user on the console. Do not worry about drawing the grid lines between game board spaces for now. Just know that the spaces are 50 pixels wide and 50 pixels high, just like this little face I drew, and the lines are 10 pixels wide. So if you want to do that, pause the video now and go ahead, and then I will show you my solution. Alright, so here's a file containing the solution to that little exercise I just gave you. So I'm going to walk you through it. These two lines here declare the x and y position variables. We give them large negative values to begin with so that the face appears off screen. We have a variable for the last thing the user said, which we'll call last comment, which I think the name we gave the string containing the last thing the user said in our chatbot in the last video, but I can't remember. And we just give it an empty string, open quote, nothing, close quote, semicolon, for its initial value. Here in the paint method, we have, oh, never mind, that's not what I thought it was. I thought I saw a problem. So this here just draws the, it sets the color to green, and then it draws a giant green rectangle. The purpose of this is to serve as a background, which will cover up the old shapes we draw, okay? And the next few lines of code, these lines here, will draw all the parts of the face at the correct positions. Then this stuff here, oh yeah, that's also going to be drawing the parts of the face at the correct positions. And these two here, again, are the ones that cover up the top half of the oval. Now we move on to the main method. This stuff here is all setup code. This is an initial print command where we just get the computer to ask for the desired starting x position in spaces, not in pixels. Then we set the x value basically to the next integer the user enters, except we multiply it by 60 because that's how far over we need to move the character's face for each space we want to move it over. Plus 10 because if we didn't do that, it would appear on the grid lines. The grid lines aren't drawn in this version of the program, but when we get to the version where we draw the grid lines, you'll see the math needs to be done this way, okay? And then this sc.nextInt command gets the computer to wait for the user to enter an int. Then we have sc.nextLine, because remember, you always have to have this after you type sc.nextInt. Otherwise, you'll have some problems later on. Then we get the computer to ask for the starting Y position in spaces. We have the same mathematical operation based on some position the user enters. Then we have the sc.nextLine to compensate for the sc.nextInt up here. Then we have the computer say the character colon as if the character is talking. Hi there, where would you like me to go? Ignore this character here, it just means new line. I don't think it's super important. I don't even know why I put it there. Probably for some old version of the program. Then this here is the frame.repaint command. It just makes it jump up to the graphics block here and run all this code so that the face will actually appear after you tell it where to appear. Then it waits for the user to say something, like to tell the character where to go. And then here we have if statements testing if the user said which direction they want to go, these ones, all the way up to here. And we just increment the X and Y positions accordingly. We have to move them by 60 because we want to move over one space. We have to move over 50 to hop over the space, then 10 to hop over the grid line. And then this else statement here is just in case the user enters something incorrect that's not one of these commands. It gets the computer to say, the character, I'm sorry, I don't understand, say again. Except it doesn't actually listen if you say again, because we've only gotten you to do this. We've only gotten it to do this once so far. Then we use the frame.repaint command just to get it to redraw everything. And as you'll notice, now that the face has already been drawn, this is where drawing the background becomes relevant. I'll show you a couple versions of this program now. So first I'm just going to run it as is. Alright, so we've drawn the green background. It's asking me to enter the desired starting X position I want in spaces. So I'm going to put 4. It wants me to enter the desired starting Y position, so I'm going to put 3. And then it asks where I would like it to go. So I'm going to say N for north. I press enter, and it moves up. And now it doesn't ask again. So now I'm going to show you a couple other variants on this. The first of which will be one where I remove, hang on, this line. So I'm going to comment it out using 2 slashes. That's another way of doing a comment. 2 slashes makes the entire line into a comment if you put them one after the other. Right. So I'm going to comment this out, stop the program, run it again. And I'd like you to try to predict what it's going to do before you watch this part of the video. So pause now. Okay, so now it's asking me to enter my desired starting X position. I press 4. And then I enter my desired starting Y position. I press 3. And then it asks where I would like it to go, but it doesn't appear yet because I removed this repaint line. But once I do tell it to go somewhere, then it will appear. But like it was never here to begin with. Well, like it was. The game considered it to be here, but it didn't draw it there. That's what I'm trying to get at here. Okay, so now I'm going to uncomment this line. And I'm going to go comment out these 2 lines that draw the background. And I'd like you to try to guess what's going to happen. Okay, I'm going to stop this program and then run it again. So as you can see, the screen is now white instead of green because it did not draw the background color. And if I put in some positions I'd like it to start at, it draws the face. Then I tell it where I want it to go. So I'm going to say north. I press enter. And as you can see, now there are 2 faces because no background appeared to cover up the bottom one. Alright, so that's all I want to show you for this iteration of the program. I am now going to show you the next thing. I'm going to move on to the next thing. Alright, hello there, I'm back. So, now the only difference between my current iteration of the program that I have and what you probably have, assuming you have been trying to do these things, I suggest you do, is that mine, not my current iteration of the program, I mean the one I showed you at the beginning. The only difference is that A, the colors are different, which we'll get to that near the end, but also the computer only asks where you want the character to move once. So I am now going to show you how to get it to ask multiple times. So you might think that I just have the code that lets the user make a move typed in 1,000 times, but I assure you I do not. The way I made the computer let the user take their turn repeatedly is by using something called a loop. The way a loop works is you write a conditional statement using the keyword while instead of the keyword if, like so. So while, open bracket, some condition, close bracket, open curly bracket, some commands, the body of the while statement, close curly bracket. Then, when the computer arrives at this while command, it checks if the condition is true, and then behaves the way it would if it were a normal conditional statement, but then after it executes the last command in the body, it jumps back up to the condition, checks if it's true, and executes the code in the body again. And after it does that, it jumps back up to the condition again and checks if it's true, and if it's true, it executes the body again, and then it jumps back up, and each time it jumps back up, if this condition proves false, then it just skips past this and never comes back, okay? Just like it would for a normal conditional statement. And as long as this is true, it just keeps hopping up. So this could happen like 1,000,000 times, for instance. So now let's have a look at some examples you see down here. Or no, sorry, here's an example of a loop. So again, here's the step that we're currently on. Here is the code. Oh, sorry, I gotta expand the window to make it visible. Expand here, expand there. That should be enough. Oh, yeah, that's more than enough. Here, so let me pull it back so these are still here, so it doesn't look too weird. Sorry. So this here's the step we're currently on. This here is the code. This little arrow again is indicating which line the computer is reading, and this here's the console where this straight line, I don't even know what you call this thing, is the console cursor. All right. So first, it's looking at int x equals sc.nextInt. Ignore the fact that I didn't declare this in the intro block like I'm supposed to. I assure you it would behave the exact same way as if I had declared it in the intro block and then just said x equals sc.nextInt here. In this case, it would have. It won't always be like that, so you shouldn't do this, but it will work in this case. So first, it reads this line, waits for the user to put in a number. Then at the next step, you can see the user's put a number in, and it's checking this condition. So they say, is x greater than 0? Yes. So it says, yeah, so then it reads this line, and as you can see, it hasn't made any changes here. Then it moves on to this line, because it's in the body of this, which is all called a loop, because it repeats itself. That's why it's called a loop. So now it's reading this line, and it's finished executing this line. So it says moving the character to, and we call this thingy here, the console cursor is still on that line. Then it's finished this line here, and it is reading the code to move the character. This isn't actually meant to be a comment. I've just put these slashes here to indicate that it's not actual code. Like this here is not what the code would be. Like there'd be some code to move it to a different position. So it reads this, it executes it. So it's executed it, and I don't have the canvas, so you can't see that anything's changed, but I assure you it would have. And then it takes another integer value for x. Again, ignore the fact that I forgot to put sc.nextLine here like I should have. I'm only going to put it in once. I'm not going to put it in on the rest of the chart because you know it needs to be there. Oh, move the 5. Sorry. Okay, problem solved. Moving on. So now that it's done this, it goes back up to the top of the loop, it checks the condition, and then again it goes through, lets the user enter a number, reads through all the lines. So in this step, lets the user enter a number, prints out what it's moving the character to, takes in another number, checks if the number is greater than 0, and now I'm just going to, I think you get the idea, so I'm going to skip all the steps until we get back to here. And the user has entered this. So then it goes, is this true? No, it's not. So in the next step, as you can see, it has chosen to skip past the rest of the loop and is now just doing this. And then as you can see, it's finished. So I think you now understand how loops work. I think you got it. So consider the two following examples, again, where I have declared variables in the main block. Bad me. But I assure you they'll work properly for this case. and try to tell me what you think, like how many times would each of these examples run? How many times would the computer go through the body? So if it proves true once and goes through, then it hops back up and it's false, and then it moves on. That's once. So do this, pause the video, try to guess, and then I'll explain it to you. Okay. So the second example would actually run 3 times, because it would go, is x less than 7? Yes, add 3 to x. X is now 3. Is 3 less than 7? Yes, add 3 to x. X is now 6. Is 6 less than 7? Yes, add 3 to x. Is 9 less than 7? Nope, move on. This one, however, would actually run forever, or until the user pressed stop anyway. It says run right now because I don't have a program running, but have a look at what it would do. It would go, is x less than 7? Yes. Y is increased by 3, so y is now 3. Is x less than 7? So is 0 less than 7? Yes. Increase y by 3, so y is now 6. Is x less than 7? So is 0 less than 7? Yes. Increase y by 3, y is now 9. Is x less than 7? Yes. 0 is less than 7. Increase y by 3, y is now 12, etc. So this here is called an infinite loop, and this is not something that you almost ever want to happen. And the reason we almost never want them is because nothing after them ever happens. Like if we had code here, like a print statement right here in the first example, it would never get executed because this would just keep executing again and again and again until the user pressed stop. However, I am going to give you one hint that I do actually have one infinite loop in my game, because like normally what you do when you're building your own game is you would put an infinite loop. Well, no, it wouldn't be infinite. Like it would have its own stop command built into the game, except because we're coding in REPL here, there's already a stop command up here built into the program that the user can press. So it's not really an infinite loop when there's a stop command here. So I think you now understand how a loop works, so I advise you to add some code to your program, which will cause it to work the exact same way mine at the beginning does, including adding the grid lines, which you actually had enough basics to generate before I showed you loops, but you can save yourself a lot of time if you use loops. Of course, I'm not expecting you to have the colors I use, because like beige and brown, those aren't pre-existing options. And the green I used is also a different shade. I made it myself. I'll show you how to do that later. But anyway, try to make a game that has grid lines and the little face moving around repeatedly based on the direction the user tells you to move it. Okay, pause the video now if you want to do that, then I will show you the solution. Okay, I'm back. Here is the solution. Here are the differences between this and the old code. First, I'm going to show you the code that draws the grid lines. So I have these two variables declared and set to 0. Okay, I'm not going to bother reading out their names. Then I have the black background, and I make it fill the whole screen. Then I set the color to green, and while the x grid line variable, so I'll just call it grid x. So while grid x is less than 1400, I fill a rectangle at position, like at x position, grid line x, which is 0 to begin with, y position 0. Y position is always 0. Note that I don't change it. It's not a variable. Width is always 10. Height is always 1500. So that's enough to, like that's, as you can see, it's much taller than it is wide. So it looks like just a line rather than an actual rectangle. And that would be the line that's like here. And then I increment grid x by 60 so that it hops over the line it just drew and then hops over the next space. And then it repeats that process because it goes, is 60 less than 1400? Yes. Draw another grid line like that, except now the grid x variable has the value 60. So the top left corner of the new rectangle we're drawing would be somewhere like here rather than over here. So it's here, and we draw another line, and et cetera, et cetera. It just keeps doing that. It hops, draws the line, 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 until we go over 1400, which is wider than the screen. Then I set it to 0 because, actually I'll explain why I set it to 0 later, all right? Then I do the same thing for the Y one, the Y lines, because right now it just looks like a prison cell rather than an actual grid, because it just has bars running from top to bottom. So the way we do this is we keep the X position constant that we're drawing the rectangle at. So the top left corner of these rectangles, these lines, the ones that run like this, is always 0. That's his X coordinate of the top left corner. But then the Y coordinate changes, so it goes down incrementally. Because you can see we increment the grid Y variable here. And again, it always has this super wide width, which is the same as this one's height, and has this super short height, which is the same as this one's width, because we want it to look like a line, not a rectangle. Like just a line with some thickness to it. And then it keeps hopping over by 60, does this till we get past 1400, and then I set it to 0, just like this one, which I'll explain momentarily. Then, as usual, we draw the face, okay? Then here in the main method, I have my setup code, I have one instance of the frame.repaint command, then I have a bunch of blank print statements because I was getting too annoyed by the random junk that was getting printed at the beginning as a result of the REPL website. Then it asks the user to enter the desired starting X position, does this stuff, you've seen this before, does the same thing for the Y position, does this to compensate for asking for the Y position, just like it did for the X. We have a loop here with a condition while X is less than some huge number, which I think is 1 billion, but I'm not going to bother to read it off right now. Basically, just something that's always supposed to evaluate the true. We have it print out, like, so the character, so while this is true, so basically in an infinite loop, we have it print out, where would you like me to go? Then print the user, not on its own line. Remember, if you leave out the ln, we went over this in the last video, it just prints it and leaves the console cursor on that line, so the user can type on this line here. It's useful for, what's it called, dialogue. Then it assigns whatever the user types to the variable last comment. Then it checks if they typed E. Now remember, we have to use dot equals like this. Oh, hang on, I've already shown you this stuff here, the test and the say again thing. Then we use the frame.repaint command. And then it goes back up here to check the condition again, which is almost always going to be true. And it just keeps looping through this. Of course, the first time we get to this frame.repaint command, it's going to go up to here, the graphics method. And now I'm going to explain to you why I reset this value. So when it has to redraw the grid lines, note that it actually won't draw them if this doesn't get set to 0, because it will have the same value it had last time we went through the graphics method. So, yeah, it'll have this here, this variable, grid X, will have like 1460 or something. That's what its value will be the first time we get to the end of the graphics block. And then when we get back to the graphics block again for the second time, and it reads through this, it will go, is grid X less than 1400? Nope, just skip it. And we want it to redraw this. Although now that I think of it, it doesn't actually matter in theory, because nothing should go over the grid lines. But if later on we had some larger character in the game that covered multiple spaces, then it would make sense to reset this. Okay, so that's my code. I'm just going to run it for you. So basically just to prove that it worked the way I say it will. Alright, so as you can see, it's drawn the black background and the green grid lines. So now I tell it the initial X position I want the character to have. So let's say 4. I can't read. Enter the desired starting Y position. Let's say 3. Then I'm just going to scroll down a little bit so you can see. Oh, I can't scroll down anymore. Okay, I think you can read that. It just says the user. So anyway, the character says, hi there, where would you like me to go? And I say north. And then the character appears because it looks like I forgot the repaint line, just like in one of the examples I showed you in my last example. But then as you can see, it asks where I want them to go again. So I can say east, 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 south, 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 west, 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 north, and so on and so forth. And if I say anything else, like hi, it says, I'm sorry, I don't understand. Say again. And then it says, where would you like me to go? Oh, and it also has the user say, I'm sorry, I don't understand. Say again. That's an interesting mistake I made. Whatever, I'm not going to bother to fix it because you clearly understand how this is supposed to work. All right, just a sec. Okay, so now you've seen this, and I don't think I'm going to bother fixing any of those two problems I just pointed out, where the character doesn't appear right away, and where this is wrong, because I'm sure you can figure out how to do it. I mean, I did it in my old example, and yeah, now I'm just going to move on to the next thing. But this is most of what we're going to be doing today, just so you know. So if you got this far, congratulations. All right, so now what I'm going to be showing you is how to create custom colors. To declare a custom color, or sorry, to create a custom color, you should declare it in the intro block. Suppose this is the intro block. I know it's just a comment, so I didn't even put the starter code, but just pretend this is all the intro block. So we go static color, capital C, American spelling. The name of it, I've written insert name here, but I know you know that doesn't have to be the name. So like you're picking a name when it's a custom color, okay? Equals, because you have to assign it a value when you declare it, I'm pretty sure. I don't think you can just declare a color and not assign it a value. So you say equals, new, this word is essential, lowercase n, new, color, capital C, American spelling, open bracket, close bracket, semicolon, between the open bracket, here, this one, and the close bracket, here, this one, and the semicolon. Put 3 integers separated by commas. The 3 ints indicate to the computer the amount of each primary color of light that should be present in the custom color you're creating. The primary colors of light are red, green, and blue, not red, yellow, and blue. Red, yellow, and blue are the primary colors of paint. They're different than the primary colors of light. I don't know why, they just are. So the first int that you enter is for red, the second one is for green, and the third is for blue. The maximum value you can use is 255. Also, when you use a custom color in the graphics block, such as g.setColor custom color, you do not need to type color.custom color like this, as if you were saying color.red, all caps. You can just say g.setColor custom color, like here. I'm actually just going to type that out right now. I realize this is not actually super clear. g.setColor, custom color, like, and where custom color is the name, you wouldn't always put the word custom color. Like if I called this color like pale skin tone or something, then I'd say g.setColor pale skin tone, not g.setColor custom color. And I would also not say g.setColor color.custom color. No, just g.setColor custom color. And then the semicolon, which you have to have after everything except a conditional statement or a loop condition. Now, you can find numerous charts on Google Images that will show you what results you get from combining various different quantities of the 3 primary colors. I don't know, maybe it'll be intuitive for you and you'll figure it out, but I'm terrible at mixing the colors to get the color I want, so I just use a chart online. If you do use such a chart, make sure it's for RGB, meaning red, green, blue values, not for hue, saturation, brightness values. That's a completely different system. It won't get you the color you're looking for. This here is a link to a site that has a chart that I like to use. I know you can't click on it. I'll probably post it in the description. All right, now I'm going to move on and show you some colors I've created. Okay, so this here is the code for my working game, all of this here. And this stuff are the custom colors I created. So the first one I called custom green. These are the numbers I used. This is the like pale Caucasian skin tone. I used these numbers. This was for the purple color I used for the character's eyes and mouth. I don't know why I used purple. I think I was originally trying to make them like a jack-o'-lantern or something, but then I realized I didn't need to use a custom color to get red or orange, so I changed it to like a Caucasian face. And then I could declare the color custom brown. These are the numbers, or these are the numbers I used. These are the ones for the purple. Okay. And other than that, I just substituted these in where I wanted them. Like I substituted the brown in for the black, the green in for the green, and the pale in for the red, purple in for the blue. And as you can see, now I have the game I showed you in the beginning. Okay, so now I'm going to enter the desired, or the X position I want to start at. So I just press like 4, maybe 3 for the Y position, and there we go. Our little character appears there. And again, it works the same way as before. No game mechanics have changed, it looks like this now. If you're wondering why I chose these colors, this was originally supposed to look like a forest, and I had made the lines brown like the forest floor and the squares green like trees, but then I realized that the face would appear under the tree rather than above it, and also you wouldn't see the face, like you just see the top of the character's head and shoulders. And I realized I wasn't going to put in enough time to do the art that way, because I just didn't care about this that much. Like, I didn't care about this game. It just had to demonstrate what I was trying to demonstrate. It didn't have to look really good. So I just left it as this turtle shell pattern. All right, now we're almost done. I'm just going to quickly show you a variable type called booleans. These hold only the values true or false. Examples of booleans, here are 2. Boolean has 1 equals false. Boolean has lost equals false. Put semicolons there. These can be used in conditional statements with no comparative operators. For example, if has lost. In fact, we could even make this grammatically correct by going boolean the player has lost. I'm just going to capitalize the P, and then just change this to if the player has lost. So as you can see, I don't need to say, like, I don't need to create an integer called the player has lost and set it to 0 and then set it to 1 if they have lost. I can just have something that directly stores true or false. Okay, so then I just have it print out game over, except I didn't put the quotes because I'm stupid, but hang on. But again, this is just like a chart type thing. This is just code you can see. I haven't actually set up anything in this file. So now suppose you wanted to have a loop execute not while some condition was the case, but while that condition was not the case. You'd need something called a logical operator. We're moving on from booleans now. Logical operators are something you can add to conditional statements or loop conditions, and they serve the purpose of the following words: and, not, or. In Java, the word and is replaced by these 2 symbols. I don't know what you call them, but you can find them above the 7 on my keyboard. The word not, which is replaced with an exclamation point, which you can find above the 1 on my keyboard. I don't know how standard my keyboard is. And then the word or is replaced by these 2 things, which I used earlier, the names of which I obviously also don't know the name of because I've already said that. And you need to use 2 of them. And yeah, that's how you replace or. And they're found above the backslash. They're on the same key as the backslash above the enter key, on my keyboard anyway. So if you put not before a condition, its true-false value gets reversed. So that's pretty straightforward to understand, I think, that you can just reverse the true-false value of a condition in a conditional statement by putting this not operator before it. But the next 2 things, the and or, operators are a little bit more complicated because they actually allow you to put multiple conditions into a single conditional statement. Now, the way they work is, if you put an and operator between 2 conditions, then the entire condition evaluates to true only if they are both true. And if you put an or operator between 2 conditions, the entire condition evaluates to false only if both of them are false. So if either of them are true, it will evaluate to true. So here are some examples of conditional statements and loops using logical operators. So first, while not last comment dot equals I want to quit, all the code that occurs each turn. So this would be something we could do if we didn't have this stop button up here. Okay, this would be a good way to allow the user to stop without having to like make a digital button they can click that says stop, because that'd be a big pain. Then we could, here's another example. So we have these has won and has lost booleans. Okay. Oh. Oops. Okay. So we say while not has won, so we reverse this value, and not has lost, so we haven't won yet or we haven't lost yet. all the code that occurs each turn, otherwise the game should end, right? So again, this here flips the value of has won, this here flips the value of has lost, and this makes this entire condition evaluate to true only if these are both true. This and this in their entirety. So actually, only if has won and has lost are both false, because they need to both get flipped to true, not flipped to false, because they only flip once. All right, the next example, we have has won and has lost again, and it goes while not has won or has lost, all the code that occurs each turn. So the second example, example 2 up here, will work exactly as the programmer wants it to, while the third one is intended to work the same way, but it will not work the same way. The condition was meant to be while not has won or has lost, so while neither of these is true, so while all of this here evaluates to false, and as a result, everything including the exclamation point evaluates to true, run the turn code. But what it's actually going to read it as is while not has won or yes has lost evaluates to true, run the turn code. As a result, if the has lost variable becomes true, then the not statement will not apply to it, and the code will continue to run until the user presses stop, and there would be no way for the user to lose the game. So at the beginning, this is false, because like has won starts out as false, but then it gets flipped to true, and because this is an or statement, this doesn't even need to get evaluated. So this evaluates to true, and it just keeps running the turn code. But then if the user loses and the has lost condition becomes true, it's not actually going to stop letting the turns go by, because the computer would read it as true and true, not true and not true, if that makes any sense. So because this is now true, the not has won and yes has lost, because both of those are true, this will still evaluate to true, and the turns will keep getting run. So if the character does something that should result in them dying, the game will then never end until the user just presses stop. Okay, to prevent errors of this kind, you can add in round brackets into conditions to indicate the order that you want the computer to evaluate logical operators, like so. While not has won or has lost, do some stuff. Okay? The logical operators and conditions with the most brackets around them are always evaluated first. Alright guys, that's everything for this video. You now have all the tools you need to create any game which is turn-based, meaning nothing happens in real time, has no spawning, no random number generators, and doesn't save your progress between program runs. Although I didn't show it in this video, you already actually do have all the tools you need to create enemies that can move in numerous different ways, damage or eliminate, or be damaged by and be eliminated by the player. You also have all the tools to create a game where the player controls multiple different characters, such as chess. Like you could make the game chess now with just the tools I've shown you, but I haven't actually shown you how to use them to do that. I'm not going to be showing you how to use them to do that in this video because it's already very long. Thank you for watching. I will see you in the next video where we will probably be showing you how to create enemies and have them spawn in. Bye.